standard sum of product expression. Okay. In a standard SOP expression, all the variables, or as I say, all the signals in the domain appears in each product term in the expression. Okay, that's what we call a standard SOP. Okay, expression, standard sum of product expression. What do I mean by domain? Okay, a domain is the type of signals that we are using. Okay, the domain is the type of signals we are using. Let's say we have something like Q is equals to AB plus A bar. Okay, so if you notice this, here you can clearly see the domain. Okay, the variables that we are using are A and B, and we have used A bar also. But if we know A, we also know A bar. So A bar is not a separate signal actually. It is derived from A. So the domain is only A and B. Okay, the domain for Q, okay, the domain for Q is actually A. The set of domain for Q can be given as A comma B. Okay, in a standard SOP expression, this is an SOP expression. Okay, this is an SOP expression. That's not a mistake, because obviously we have a product here, we have a product here, we have the plus symbol to sum it up. That's all fine. Okay, that's all fine. But what I'm telling is, in a standard SOP expression, okay, all the variables in the domain should be present. Okay, you can't have only part of the domain. Here we are only using A bar. We are not using B. Okay, we are not using B here. Here we have AB, that's fine. But here we are not using B. So this is an SOP expression. Yes, this is an SOP expression. Is this an SSOP expression? No, this is not a standard SOP expression. What is the justification? Because we have A bar. Because it has only A bar as a term. As a term. Okay. So similarly, let's say Z is given as AB plus AC plus BC. Well, is this SOP? Yes. This is a sum of product expression. Yes, obviously. But is it standard sum of product expression? No, this is not SSOP. Why is that? The domain, as we clearly see, the domain has three variables, A, B, and C. Okay, A, B, and C. But what are we using? Here we are using only AB. Here we are only using AC. Here we are only using BC. So can it be SSOP expression? No, it cannot be SSOP expression. But what's the thing that we can do is, we can actually come up with SSOP expression by using a SOP expression. Okay, that's what I'm going to teach. Okay, that's what I'm going to teach. So let's say the first question is given as Q is equals to AB plus A bar. Obviously, the example we have already used. Let's look at this. How can we do this? Well, what you have to do is, you just have to do a circle arrangement. That's all. So what you can do is, you can write this down as AB plus A bar into 1. Okay, you can write this down as AB plus A bar into 1. I'm just using the identity rule. Okay, identity law. So this can be given as AB plus A bar into B plus B bar. Why? We know 1 is equals to B plus B bar, or A plus A bar, according to inverse rule. Okay, so now if I expand it, what will I get? I will get AB plus A bar B plus A bar B bar. Okay, now you can see this term has all the variables in the domain. This term has all the variables in the domain. This term has all the variables in the domain. Okay, the domain contains A and B. Okay, the domain contains A and B. Okay, the domain contains A and B, and all these variables or signals are used in its different forms. Okay, A and B means you can use A, B, or A bar, B bar. Okay, that's all. So this is in SSOP form. This is in SSOP form. This is not in SSOP form. But this is in SOP form. Obviously, we have the product summed up by using OR gate. That's all fine. But is it in SSOP? No. But now it is in SSOP. Okay. So this is very important. Let's do another question. Okay. Let's do something with three variables. Let's say we have A, B, C plus A, B plus B bar. How can we do this? Well, is it in SOP form? Yes, it is. Why? we have three products summed up by using two OR gates. Okay, that's fine. But this is not in SSOP form. Why? We have A, B and we have B bar. So first of all, what you have to do is ABC, we can write it down directly, no worries. But AB can be given as AB into C plus C bar. Okay, I'm just skipping one step. Well, we won't have to. Okay, we'll just do it step by step. AB dot 1 plus B bar into 1. And we can give ABC here. And here AB dot 1 can be given as AB into C plus C bar. Plus here for 1, what are you going to give? You have to be very careful about that. What are you going to give? Well, you have to give AC plus AC whole thing bar. Don't you think? You have to give AC plus AC whole thing bar. Why? Here we are giving C plus C bar because C is missing. So we have to get C plus C bar. Here we are missing AC. In this term, we are missing AC. So we have to give AC plus AC bar. But if you expand this, what will you get? You will get ABC plus ABC plus ABC bar plus AB bar C plus B bar AC whole thing bar. Okay, now we have a dilemma. Two dilemmas actually. What are the two dilemmas? First thing, ABC is repeating twice. Okay, and here we have AC whole thing bar inside one of the terms. And we know in a SOP format, we can't have that. We can't afford to have that. So first of all, let's face the dilemma one. What's the first dilemma? Two repeating same terms. Well, x plus x is equals to x according to the idempotent law. Okay, so you just have to write it down once. If you get it twice, no worries. Obviously, it's going to happen. Don't worry. Just write it down once. So you'll get ABC plus ABC bar plus AB bar C. Now, what you have to do is just break it down. So you will get B bar, okay, B bar into A bar plus C bar. Okay, you'll get A bar plus C bar. You will write it down. No worries. So ABC plus AB C bar plus A B bar C plus A bar B bar plus B bar C bar. Well, now the problem continues. Why? Here we have only two terms. Here we have only two terms. Okay. Again, you have to do the first step again. Okay. So I'm not going to write down all those things like dot one and stuff. Okay. I'm just going to directly write the answer. Okay. So I know I will have to put 1 here and then I have to change it to C plus C bar and find the answer. So it will be A bar B bar C plus A bar B bar C bar. Plus here also it's the same thing. I'll get A B bar C bar plus A bar B bar C bar. Okay. So that's it. Now finally check for the same terms. If you have the same terms, you can eliminate them. So ABC is fine, ABC bar is fine, AB bar C is fine, A bar B bar C is fine, A bar B bar C bar is fine, A B bar C bar is fine, A bar B bar C bar is again. Okay, this is repeating 2 times. So the final answer, okay, the final answer Z, okay, the final answer Z can be given as ABC plus ABC bar plus A B bar C plus A B bar C bar plus A bar B bar C bar. So this is not in SSOP format. This is not in SSOP format, but this is in SSOP format. We have just expanded this. That's all. Normally we go from the opposite direction, obviously. But yeah, it's fine. Okay, it happens. It's fine. Okay, it happens. All right. Don't I know you will have some doubts like if I simplified this, okay, you might say if I had simplified this, I would have get AB plus B bar. Okay, so which is equals to A plus B. So the output will be actually AB plus AB bar plus BA plus BA bar. So the final answer will be AB plus AB bar plus A bar B. That will be the final output. I don't even have to incorporate C, right? Because if you simplify this, obviously C is going to hide according to redundancy law. But in this one, they have said the domain has 3 signals. They have said the domain has 3 signals. So we have to incorporate all the signals possible. Whether we like it or not, we have to incorporate all the signals. Okay, we have to incorporate all the signals. Okay, you can't just hide a signal and go ahead with it. So keep that in mind. So SOP means you're giving the terms. Okay, the terms are given in sum of products forms. Okay, the terms are given in sum of product forms, any output. And in SSOP, the variables, I mean, the terms should have all the variables in the domain. Okay, and we can't extend the bar, overhead bar, for over more than one given variable. Okay, so why is SOP important? Well, this is important in 2 ways. Okay, one way is that when we are using min terms, yeah, when we are using min terms to find the output. Okay, when we are using using the min terms to find the output of a truth table, that is one. And then the second one is when we are using, since this is in the, you can clearly see this is in OR gates, right? This is in the OR gates form. So when we are using, when we will learn how to use only NOR gate to find answers. Okay, we will learn in the future. So for that also, you will need SOP. Okay, so in the next video, I will teach you about POS. So stay tuned.
Thanks for watching the 13th video in our Logic 8 series. If you found this deep dive into SSOP and the techniques for converting SOP to SSOP helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master Logic 8. Follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye.